Hi everyone. Today let's talk about section 5.4, working with integrals. Big idea. The average value of an integrable function on an interval is the area under the curve divided by the length of the interval. Furthermore, the mean value theorem guarantees there is a point in the interval such that the function value evaluated at that point equals to the average value of the function over that interval. Big skills. You should be able to calculate the average value and find points at which the function value equals to the average value. Okay. First, let's look at integral of even and odd functions. So let a be a positive real numbers and let f be an integrable function on the interval from minus a to a. If f is even, so what happened? Let's see. Can you give me an example that is an even function? Well, x squared, right? Okay, x squared looks like that. This is x squared. Okay, so this is an even function. Okay, so we look at the integral, so the interval from minus a to a. Okay, what is special about this integral? You can see the area because it's the even function is symmetric about the y-axis. So you can see the left area actually equals to the right area. So that's why the integral from minus a to a f of x dx equals to 2 copies of the integral from 0 to a. What happens if f is an odd function? Well, if f is an odd function, can you give me an example of an odd function? Probably x cubed, right? So x cubed looks like that. Then we have minus a and a. Okay, so the integral from minus a to a is this guy. Okay, what happened here? Well, because this area is below the x-axis, it will be negative, and this area is above the x-axis, it will be positive. And you can see because the odd function is symmetric about the origin. So those two areas actually are the same magnitudes, but because they are of different sign, they will cancel out. So that's why for odd function, the integral from minus a to a f of x dx will equals to 0, no matter what kinds of the odd functions. Okay, as long as it's odd function, then this integral equals to 0. Okay, and then with this in mind, let's work on example 1. Okay. So example 1 evaluates the integral from minus pi over 2 to pi over 2 of cosine x minus 4 sine x cubed. Okay, first of all, let's split the integral because here we have cosine and sine cubed. So cosine is an even function and sine is an odd function. Okay, so how do we know a function is even or odd? So a function is even if f of minus x equals to f of x, and a function is odd if f of minus x equals to negative f of x. Okay, and even function is symmetric about the y-axis. Odd function is symmetric about the origin. Okay, so we can split it. Let's split it. We have integral from minus pi over 2 to pi over 2 cosine x minus, we can move the 4 outside, right? So 4 minus pi over 2 to pi over 2 sine x cubed dx. Okay, so do you know what cosine looks like? So cosine looks like that. So this is cosine. You can see it's an even function. So because it's even function, the integral from minus pi over 2 to pi over 2 is 2 copies of the integral from 0 to pi over 2. Okay, how about sine x cubed? Well, we know that sine, so we know sine looks like that. Okay, but this is a composite function. We know sine is odd. This is a composite function. It's like sine composite with x cubed, right? So we know x cubed is also odd. Okay, so when you have a composite function of odd, and odd function will give us odd function. Okay, so let me write it down. Composite function. Composite function of odd and odd is odd. Okay, so what happens if we have a composite function of odd and even? Of odd and even is gonna be even. Okay, how about composite function of even and even is even? Okay, so why is that? You can imagine, what does even function do? It eats the negative, so it's gone. Okay, the odd function, the negative stay outside. Okay, so when you composite the odd function and odd function, the negative stay there. But when you composite the odd function and the even function eat the negative. So the negative is gone. That's why the answer is even. Composite function of even and even, they eat the negative, so it's still even. I can also give you an analogy. So do you know our blood type? Our blood type, if you have II, that's the O type, right? Your blood type. This is analogy. When you have AI, this is A type, right? When you have BI, we have like a B type. So you can think of like the odd function. The odd function is like the I, and the even function is like the A. So when you okay, we don't need a B type. So when you have I and I, you get the O type. When you get A and I, you get A. When you have A and A, you also get A type. Okay, so this is an analogy of this odd and even function. Okay. So here we know sine cube is odd. So that's why integral from minus pi over 2 to pi over 2, this is just 0. That equals integral of cosine is sine. So sine evaluate from 0 to pi over 2, and this is 0, okay? This guy is 0. So that equals 2 sine of pi over 2, subtract 2 sine of 0. So sine of pi over 2, we know the pi over 2, that's 1. So 2 minus sine of 0 is 0. So the answer is 2. Okay, so that's part A. Let's look at part B. Evaluate the integral from minus pi over 2 to pi over 2 of sine absolute value of x plus x squared. Okay, so here we know this is like composite function. Absolute value of x is an even function because is symmetric about the y-axis. Okay, when we composite an even function and an odd function like sine x, we will get an even function. So sine of absolute value of x is actually even, and x squared is also even. So this function is an even function. Okay, x squared is also even. Okay, so for even function, the integral from minus pi over 2 to pi over 2 is 2 copies the integral from 0 to pi over 2 sine x. So actually here we don't need absolute value of x because x is greater or equal to 0. absolute value of x is just x. So this is a good thing of restricting the interval in between 0 and pi over 2. So then we can get rid of the absolute value of x. Okay? So that is integral of sine is negative cosine, right? Negative cosine. And we have the 2 here because we distribute. The integral of x squared is x cubed over 3. Evaluate from 0 to pi over 2. So we plug in pi over 2 first. And then this is 2 pi over 2 cubed. So pi cubed 2 cubed is like 8 minus 0. So negative become positive 2 cosine 0, and negative when we plug in 0 is gone. Okay, so cosine 0 is 1. Cosine pi over 2 is 0. So our answer is, you can see 2 and 8, they cancel. So this is the same as, so 2 and 8 and is the same as you multiply by 3 in the denominator. Because A over B over C over D equals A over B times D over C. And 3 is like the C. So the C is in the denominator. Okay, and then that plus 2. 2 times 1 is 2. So that's why 2 and 8 cancel. We have pi cubed over 12 plus 2 is our final answer. So far so good, everybody? Okay, now let's continue. What is the average value of an integrable function on the interval from A to B? Okay, so here let's draw a picture. Let me draw a picture. I love to draw a picture because for the theorems, I can help you like relate to an analogy or some story. So you can use the story to kind of understand and remember this theorem. Okay, so my story is, imagine we are in a swimming pool. It's a very nice sunny day. Okay, and the proof here. Okay, so this is what happened if nobody jumped into the pool. Okay, now, a person is you. You jump into the pool. Okay, so you come over here. And you jump into the pool. What happened? Your water just... Okay, so this is the water level gonna change. What can you say about this area, the blue area and the purple area? Let's assume you're very, very skinny, so we can ignore your volume, okay? Alright, so what's special about the blue area and the purple area? They are the same, right? If we neglect your area. So the blue area equals to the purple area. Okay. Let's say the blue water level is like the function f. Okay, and let's say this is A and this is B. Then the blue area is the integral of from A to B f of x dx. So that's the blue area. Okay, how about the purple area? Well, the purple area is like a rectangle where the base is B minus A. How about the height? Okay, so let's talk about the height. Let's call it h for now. Okay, so the h is actually the average value of the integral function f. Okay, because it's like, oh, you jump into the water and then you see the water level change, but after the water settle down, the height becomes the average value of that area. Okay, so that's why you can solve for h. H is integral of A to B f of x dx over b minus a, and this is the average value. Okay, so you can use this story to think about the average value. Okay, so the average value is you integrate everything, okay, the area under the curve from A to B divided by the length of that interval, b minus a. Okay, so that is the average value. And we use F bar to denote the average value. Okay, so what does the mean value theorem for the integral tell us? So it says, let f be continuous on the interval AB. Then there exists a point C in AB such that f of C equals to the average value. Okay, because f is continuous, from this picture you can see we have some point C. Okay, so here are some point C such that f of C equals to the, so this is C such that f of C equals to the average value. Okay, so we can find those C. So keep those in mind, keep this cute picture in mind. Let's work on our examples. Example 2, find the average value of the function f of x equals to 1 plus x squared on the interval minus 1 to 2. And then find C such that f of C equals to the average value. Okay, so let's draw a picture. X squared plus 1, we know is a parabola. So when x is 0, we get 1. When x is minus 1, we get 1 plus minus 1 squared is 1, so 2. And when x equals to 2, we get 5. Oh, let's say this is 5. So this is a picture look like, okay? We want to find the average value. So we first want to, so imagine this is the water after you jump into the pool, okay? So let's figure out those area. So the area equals to integral from minus 1 to 2, 1 plus x squared dx. Okay, integral of 1 is x. Integral of x squared, we add 1 to the exponent, so it becomes x cubed over the new exponent, which is 3. Evaluate from minus 1 to 2. So we plug in 2 first. So 2 plus 2 cubed is 8. Minus, we plug in minus 1. When we plug in minus 1, this is x become minus 1. And minus 1 cubed is still minus 1. Okay, now let's see what happens. So this is 2 plus 8 over 3. Minus minus become plus. Minus minus become plus. Okay, so that's 3 plus 8 over 3 plus 1 over 3 is 9 over 3, which is, again, 3. Oh, so the answer is 6. So 6 is the area. So far, so good, everybody? So now, what is the average value? So the average value equals to, what's the length of the interval? Okay, the length of the interval is 2 minus negative 1. So 1 over the length of the interval times the area. So the area, so that's why 2 minus negative 1 is 3. And then the area is 6. The average value is 2. So that means, ooh, after the water settles down, what does it look like? It looks like this guy. Okay. So far, so good. And then next, the problem asks us, okay, by the mean value theorem, we know because the function is continuous, there must be a point C such that f of C equals to the average value. Wow, it looks like this is the 1 and the minus 1, but let's check it out, okay? We cannot just guess from the picture. So, we by the mean value theorem, okay, there is a c in the interval -1 to 2, such, oh, by the way, this notation means in, okay? But if you don't like it, I can just put in there. Okay, so there is a c in this interval such that f of c equals to the average value, which is, the average value is 2. Of what is f of c? Well, that means you plug in your x equals to c in the expression of f. So that's 1 plus c squared equals to 2. Solve for c. Oh, let's subtract 1 from both sides. And then let's take the square root. When we take the square root, we get plus or minus 1. Ooh, that's exactly what we get from the picture, right? So here are the c values such that f of c equals to the average value, and it match with our pictures. Yay! So far so good, everybody. So if you want to decompose this into steps, so the steps are: first, we compute the area, which is the interval. Okay, so that's the first step. And then you compute the average value, and then you say by the mean value theorem, there is a c such that f of c equals to the average value, and then you look at the function f, and then solve for c. Okay, so this is 3 steps. So I hope that you can pause the video and try to work on example 3. Okay, so what is the first step? So if you know how the function looks like, you can draw a picture. It can help you to understand. So this is the square root. Square root is 1 and 4. So 1 is 1. 4, square root of 4 is 2. Okay. So this is the area. Integral from 1 to 4 square root of x dx. Well, what is square root of x? Well, that's the same as x to the 1/2. Well, how do you integrate x to the 1/2? Power rule. You add 1 to the exponents. So 1/2 plus 1 is 3/2. And then we divide it by 3 and multiply by 2. Okay, and then we can evaluate from 1 to 4. So when we plug in 4, what happened? So 4 to the 3/2. Square root of 4 is 2. And then 2 cubed is 8. And then minus when we plug in 1, so which is 2 over 3. 2 over 8 minus 2 over 3. 2 times 8 over 3. That's 16 over 3 minus 2 over 3. So that is 14 over 3. So far, so good. So that is the area. And the second, what is the average value? F bar equals to, what's the length of that interval? 4 minus 1, right? And then 1 over 4 minus 1 times the area. The area is 14 over 3. 4 minus 1 is 3, so that's 14 over 9. Okay, that's the average value. Alright, if we draw a picture, then 14 over 9 is bigger than 1, but less than 2, because 2 is like 18 over 9. So 14 over 9 is slightly smaller than that. So it's like this picture. This is the average value. Okay? And by the mean value theorem, there is a point C such that f of c, so by the mean value theorem, there is a c in the interval from 1 to 4 such that f of c equals to the average value, which is 14 over 9. What is f of c? Well, that's square root of c. Okay? Oh, how do we solve for c? Square both sides. So 14 squared, 9 squared. What's 14 squared? 196, 9 squared, 81. Okay, so this is the C value. Do you have the same answer? Good, let's continue. Okay, so example 4. Find the average value of the function. Okay, so yeah, you can also pause the video and try to work on this problem. After you're done, you can continue to play the video and check our answer together. Are you done? Okay, let's go over it. What is the first step? Okay, so first step is the area. So area integral from -2 to 2, and then this is 4 minus x squared dx. Do you know how to integrate this function? Well, square roots, we don't have a formula for square root of something minus something squared, right? But if you can remember, in session 5.2, we talk about how to find the integral by the area of some geometry figures. So what do is we call this guy y. So y equals to square root of 4 minus x squared. We square both sides. We get y squared equals to 4 minus x squared. And then we can move the x squared to the left. Oh, what is this? This is a circle center at the origin with the radius, is it 4? No, it's 2. So what's the picture looks like? Center at the origin with the radius is 2. So this is 2, this is 2, this is -2, this is -2. And square root is the upper half, okay? So the upper half from -2 to 2, this is the area, okay? So that's why from the picture is half of pi r squared. R is 2, so 2 squared. Oh, we get 2 pi is the area. So far, so good. That is the first step. Okay, second step. What is the average value? Well, the average value is, what's the length of that interval? 2 minus -2 times the area. Wow, 2 minus -2 is like 2 plus 2, which is 4. So 2 pi over 4, that is pi over 2. So the average value is pi over 2. Oh, you know pi is like 3.14, right? So pi over 2 is like 1.7 something. So it's like here. So that's why, okay, if the water settle down, then this is what it looks like. Okay, okay, I don't want to put too many lines there. Okay, so the third step, by the mean value theorem, we know there is a C. Actually, from this picture you can see we have 2 points. Okay, one positive and one negative. So there is C in -2 and 2, such that f of C equals to average value, which is pi over 2. But what is f of C? Well, we plus C into our function. 4 minus C squared equals to pi over 2. Let's solve for C. We square both sides. 4 minus C squared is pi squared over 4. And then we move the C to the right and move the pi squared over 4 to the left. And then we take the square root. When we take square root, we have plus or minus. So far, so good, everybody. So let's plug this in our calculator. I got my answer approximately equals to 1. So plus or minus 1.24. So here, somewhere here. It makes sense. If this is 1, then this this looks like somewhere closer to 1 than to 2. Okay, so we get the C is approximately plus or minus 1.24. And we get 2 values and it matches with our graph. Okay, so for this problems, you don't have to draw the graph, but actually the graph can help us to understand. And it can help us to double check the answer as well. So you can see from the picture, we know we're supposed to get 2 C values. Yeah, we indeed get 2 C values. Okay, so today we learned about the integrals of f functions and even functions. Even functions, integral from minus a to a is 2 copies of the integral from 0 to a. F function, the positive area and the negative area cancel out, so we get 0. And then we talk about the average value. Average value is like it's a summer day, okay, very sunny day, and maybe in the summer you jump into the pool and then the water level raise up, right? So we have a function of f, and after the water settle down, we can get a rectangle. So what is the same, the area is the same, okay? So that's why the area, which is the integral from a to b of f of x dx, equals to the area of the rectangle, b minus a times the average value. Okay, and then we can use the mean value theorem because the f is continuous, so there must be a c such that the function value equals to the average value, and then we can solve for C. So I also want to point out that this mean value is a little bit different than the mean value we learned before. So this is a mean value theorem for integral. Okay, so what was the mean value theorem we learned before? Okay, so let me use a different color. How about yellow? Okay, so we mark what is the mean value theorem we learned before. The mean value theorem we learned in session 4.6. Okay, so one main use is we can use the mean value theorem and the intermediate value theorem to show a function or equation has exactly 1 root. The other one is we can use mean value theorem to show like a function satisfy the mean value theorem and find a number guaranteed to exist by the mean value theorem. So the mean value theorem tells us first 2 conditions. F is continuous and f is differentiable. So after we satisfy those 2 conditions, then there is a c such that f prime of c equals to f of b minus f of a over b minus a. So the picture is, well, we have a here and b there. This is f of a, f of b. Okay, so we have a secant line passing through it. So the mean value theorem tells us there must be a point that the slope of the tangent line at that point is equals to the slope of the secant line passing through the 2 endpoints. Okay, so this is the regular mean value theorem, and then here we have the mean value theorem for the integral. So you can see we have the integral here and we have f of c. Okay, so actually, how do we come up with the mean value theorem for the integral? Well, you just plug in your f is this integral. Okay, then think about it. Let's say we plug in the antiderivative, so we apply the mean value theorem for the antiderivative of like capital F, okay? Then capital F of b minus capital F of a, while over b minus a, this guy is exactly this definite integral. And then here we get f prime of c, well, derivative of capital F is small f because capital F is the antiderivative of small f. Okay, so how do we get the mean value theorem for integral is we apply the mean value theorem to the antiderivative of the small f. So far so good, everybody? Okay, so this is how they are connected. Okay, all right. So, and that's it for today. Have a good day. Bye.